Hi everyone, my name is Dhruv Saini. I am your host for this session and today we will be talking about policies in Realize Operations Manager. Policies is one of the most important and one of the most critical configuration available to us in Realize Operations as this basically govern how your environment will be monitored in terms of alerts, badges, statistics, thresholds, etc. So what basically a policy is? Policy is a set of rules which define how vROps is going to monitor the environment. It basically allows you to modify the way vROps analyzes and presents the data. Let's take an example. In your environment, you have two types of servers, business critical servers and test servers. Even in the worst situation, you do not want your business critical servers to go down. And on the other hand, test servers are not so critical and losing them will not have much impact on your business. So, for business critical servers, availability is the priority, and for test servers, capacity of the data center is the priority. You will be needing a different policy with proactive monitoring for business critical servers and a different policy for test servers with slightly different set of configuration. So, what all makes up a policy? Policy includes settings related to metrics, symptoms, alert, badges, thresholds, buffer, etc. Now let's move to the console to have a closer look of how policy works. This is our lab setup of Realize Operation 6.7. Let's log in. This opens the home page. Navigate to the Administration tab and then to Policies. Here we encounter with two tabs, Active Policy and Policy Library. Active Policy lists out all the policies which are currently active in the environment. Here we can see that two policies are active at this moment. We can also see the number of objects it is governing and its priority. Priority is important because if there is an object which somehow comes under two different policies, then can you tell which policy will govern that object? The answer is the policy with the higher priority will govern it. Remember this thing for realize operations that only one policy will govern a particular object at a particular time. Now what does this D mean? It is telling us that it is the default policy. Any new object coming into realize operations will be governed by this policy if not specifically changed. You can also create your own policy and make it as default using this option available here. Policy library contains all the policies that are there in the environment, whether it be active or inactive. Some policies come into realize operations by default, and some are configured by the user as per the use case. If we select any of the policy and go to the Details tab, it will give us the configuration we currently have for this policy. Here, we can see the locally defined settings of metrics, alerts, and symptoms. By locally defined, I mean that inherited configurations have been changed by going specifically in this policy. We can also see the complete configurations of alerts, symptoms, etc. Don't get confused about these terms, we'll be talking about them in just a moment. In Related Objects tab, we can get the information related to the number of objects and groups this policy is affecting. Here, we can see that one groups come under this policy which contains 7 objects. Now, we will create a custom group. Navigate to the Environment tab and then to the Custom Groups. Custom groups are logical grouping with certain objects in it. Here, this step is important because we will be attaching a new policy to this group which will contain some VMs. Remember that a policy is only active when it is attached to a group. Click on the green plus icon, provide a name, group type as per the use case. Here I am giving as environment. Now we will be specifically adding VMs which we want to monitor using this policy. So we'll move to the all objects, then to the vCenter adapter, and then to the VM folder. Then we will specifically add the VMs. We can preview our group. Here we can see the two VMs are added in this group, and then just save it. As the group has been made, let's now make a new policy and see what all configurations are available for customization in Realize Operation 6.7. The reason of specifically mentioning the version of vROps as 6.7 here is, in previous versions the configuration which could be customized were much more as compared to this version. Now we'll navigate to the Administration tab and then to Policies. We can create a new policy in the Policy Library tab. Click on the green plus icon, provide a name, a description. The Start with options gives the capability to use an existing policy as a base. All the settings will be inherited from this policy and we can make changes into them according to our needs. At this moment, vSphere solution default policy is selected and we can choose any other policy as per our use case. This tab gives us a preview of the policy with all the settings inherited from the base policy, which in our case is the vSphere solution's default policy. This preview includes configuration inherited from the base policy as well as the configurations defined in this policy. So this tab here shows the complete configuration of the policy and this tab here shows the configurations which have been changed locally. We can see the number of metrics, alert, symptoms, enabled or disabled. Apart from this, we can see other configurations which are inherited like workload automation and risk level settings. We'll be discussing them in just a moment. We can also see the threshold which is inherited from the base policy for particular object types. For example, if I select the cluster compute resource and click on this icon, we can check what all thresholds have been set. So here we can see the threshold for workload, time remaining, capacity remaining, etc. In the Analysis tab, we can set the time remaining risk levels as conservative or aggressive. Remember, you cannot change any configuration until you unlock it using this option available here. Time remaining represents the amount of time before an object runs out of capacity based on the historical and current trends. Conservative will give you a value depending upon the upper bound projections rather than the actual value, and aggressive will give you a value depending upon the mean projection. If we filter out any object type, for example, if I filter out the cluster compute resource, we will have configurations available for workload, time remaining, capacity remaining, compliance, and maintenance schedule. On unlocking the workload, we can make changes to the thresholds by moving the slider. That is, if the workload is from 0 to 80, it should be green, means workload is fine. From 80 to 90, it should be yellow, which means the workload has reached to a warning level. And if the value is between 90 to 100, it should be red, means the workload of the object is critical. Remember, this is only an example. We can set values as per the use case. Similar type of configurations can be done for the time remaining and the capacity remaining. The values are selected based upon the type of object this policy will be monitoring. For example, we will have proactive configurations for our critical servers. So, we will configure thresholds in such a way that it moves to critical even when the value is small. So be careful while selecting the values for threshold. We can also add a maintenance schedule here so that the monitored objects go into maintenance at that particular time. For adding that, you will first have to configure a maintenance schedule in the Administration tab. Remember, metrics are not collected at the time of maintenance. Next, in the Workload Automation tab, we have configuration related to the optimization of workload. If I move the slider to the balance side, it will spread the workload evenly over the available resources. And if I move the slider to the consolidate side, it will put the workload on few clusters as possible. In simple words, balance is good for stable population. That is, VM will move across clusters to maintain the balance. Consolidate will help to save license and power costs by moving VMs to fewer clusters as possible. If I move the slider in between to the relief stress, it will help to reduce the workload contention. Cluster headroom will reserve the cluster capacity for different purposes like failover, performance, etc. In simple terms, as soon as the cluster capacity reaches 50%, when the headroom is also 50%, no more machines can be moved into the cluster. In tag-based VM placement, we can set the criteria to move VMs to a particular cluster with matching tags. Next, in the advanced settings, we can customize if we want to change the data store as well when VMs move from one cluster to another. That is, if we want to enable storage vMotion or not. In Collect Metrics and Properties tab, all metrics with their different properties are listed out. If we want this pane to display metrics of any particular object type, then we can filter it out here. Now we can see there are around 490 metrics for virtual machines, some of which are active and some of which are inactive. So how do we check a metric is being collected? In the state field, if it is green local, then the metric is locally enabled and it is being collected. If it is red local, then the metric is locally disabled, means the metric is not being collected. For the inherited, we have two types. Inherited with a right tick, which means a metric is coming from the base policy and it is being collected. Inherited with the circle sign, which means the metric is not being collected. Next is the KPI. In the KPI field, we have same options of enable and disable. KPI stands for Key Performance Indicator. If it is enabled, then the particular metric will act as a key performance indicator for the particular object type. Here, DT stands for Dynamic Threshold. If we want realize operations to calculate the dynamic threshold for any metric, then we can enable that as well. We have similar options of enabling and disabling. Here, yes represents a locally enable and no represents a locally disable. Enabling any metric to calculate the dynamic threshold will increase the analytics load on the vROps cluster. So, if you are enabling that, make sure you use it. The options above are used to filter the metrics. For example, in the state field, if we select the locally enable, then it will filter out only those metrics which are locally enabled. Here, we can see only two metrics are locally enabled. In the Alert and Symptoms tab, we can check the alert definitions. Enable disable them as per the use case. For example, the VMs which we will monitor using this policy do not require the first two alerts shown on the console. So what we can do is we can disable them. Symptom definition shows all the symptoms, their adapter type, object type, state that is enable or disable, and the condition. We can leave the condition as default or we can override the threshold specifically for this policy. So, if we want to override the threshold for this particular symptom, we can do that using this option. Just make the changes and click on apply. Again, this is decided by the workload we will be monitoring using this policy. Here, we can see that the threshold has been changed. Last and most important step is to apply this policy to a group. As I have told you before, that a policy is only active when it is attached to a group. We created a group by the name of test. Just select that and click on save. As soon as the policy is saved, it comes in the active policy tab. We can check the priority and make the changes if needed. For making the changes, just drag and drop the policy. Now, a new policy has the first priority. Consider an object coming under both these policies. Can you guess which policy will govern it? Yes, you guessed it right. A new policy will govern it. Now we will go to the particular VMs which were in that group that we attached to the policies to check if they are being monitored by the new policy or not. We will just search them here. Here are those machines. At the top right corner, we can see that it is being monitored by a new policy. At last, we will discuss the parent-child relation. In real-life operation, this concept says that when we create a new policy using an existing one as a base, then the new policy becomes a child of the existing policy. Any configuration change in the parent policy will also change in the child policy. Hence, we need complete understanding of what we want to achieve in policy, as any small change can affect the complete monitoring solution. So guys, that's all for now. Thanks for viewing and stay tuned to our channel for more on vROps Operations Manager.